So last time we were here in class, we had talked about solving two variable systems, right? And I'd asked you to do a couple of homework assignments involving those topics. Let's start with questions. So if anybody has any questions from those assignments, let's start there. So if you had things that you weren't sure about, or you couldn't figure out, or you're not sure what to do, we'll take a moment there and kind of clarify those. So if you were having trouble finishing the assignment, we can get that finished. Again, those two assignments are part of the homework check on Sunday. But please don't be waiting until Sunday to do all your math homework. It works much better if you're doing it along the way, at least starting it. Paradise? Okay. And I've noticed on like some of your digital turn-in things that, do you go by Paris? Is that what you'd prefer me to call you? Okay. I just figured I'd ask, you know. I don't want to be calling you some name that you don't really like, so. Okay. So this is number 4. We just asked to identify the solution for the system pictured. So we had talked about how that the solution to a system was equivalent to a point that lies on both lines. So in that case, we're just talking about the intersection. So if I look at that, it appears that the x value is there at -1. And if we trace over, it appears that the y value is at 3. So there's our solution. And that's it. So once you have the picture, we're just looking for the intersection. Okay? Joe?
It's more like a general question.
Sure.
On this page, the graph one.
Okay.
So when you put the y equals into your calculator, it'll like give you a graph, obviously. For the test, if you want us to redraw that graph, or just put the S up.
Yeah, so there'll probably be on a test or whatever, I might give you a problem like this where I ask you to draw the graph and show it. Or I might give you a question like this where I just literally ask you to tell me use your calculator to give me the solution. I think both are appropriate things to ask. If I ask you to do it with your calculator, I don't need anything other than the answer. And that would probably just be like a right or wrong question, you know, like a 1-point question, whether you can do this or not. As there's not a lot of like immediate math skill involved. It's just like, do you understand how to use this tool? But yeah, if I asked you to do it on your calculator, I wouldn't ask you for anything more than an answer. Does that feel okay? Yeah. Hi, Megan. What's up? Sure. So just as a heads up, on homework 3, both the answers to 7 and 8 are pretty awful looking fractions. So if you got something and you're like, that can't possibly be right, well, don't be so fast. It could possibly be right. So just as an aside, for homework 7, the answer you would have gotten was 181 over 19, comma, -179. And for 8, the answer should be -59 over 57, and then 52 over 57. So just as a heads up, like, there you don't have to get like nice, neat whole number integer answers. You can get pretty disgusting looking fractions, and that's okay. I'm happy still to do 7, but I thought I'd lead off with the actual answer to 7 is a pretty terrible looking fraction. So if that's where you were heading, Megan, you probably weren't doing anything wrong. But let's do 7 anyways, right? Okay. So on 7, we're asked to do this using elimination. So the first thing that I would do in order for me to be able to do elimination on this problem is I have to get everything to line up vertically. So I'm going to put the x's and y's on one side and then the constant on the other. So this first equation, I'm going to add 4x to both sides and then subtract 9 from both sides. And then similarly, for the second equation, I'm going to subtract 9y from both sides. And now I've got this set up in a way where I can start my elimination. Is that okay, Megan? Okay. So I'm going to either pick to eliminate the x's or y's. If I look here, it doesn't really seem like there's any advantage to one versus the other. I'm going to pick the y's, though, because the numbers involved are a little bit smaller. I'm going to be multiplying by 5 or 9, and those are both numbers I'm pretty confident I can do the multiplication in my head with, but it doesn't really matter. So if I refer to the first one as equation A and the second one as equation B, I'm going to do 9 times equation A plus 5 times equation B. That'll make the y's 45y and negative 45y, so when I add them together, they'll cancel out. So if I do that, 9 times 4 is 36, 9 times 5 is 45, and 9 times 9 is 81. And then 5 times 11 is 55, 5 times 9 is 45, and 5 times 20 is 100. So when I add these down, I get negative 19x, the y's cancel out, is equal to negative 181. And if I divide both sides by negative 19, I get that x is equal to 181 over 19. So far, so good? Okay. So to solve this now, I'm going to plug this value for x back in somewhere. I'm going to choose to plug it back in here because the numbers involved in this, the coefficients are a little bit smaller. So it just makes the arithmetic a little bit easier. It doesn't really matter where I plug that back in, though. Any location is going to be okay. So when I do that, I get 9 plus 5y equals negative 4 times 180 over 19. So if I do 4 times 181 over 19, remember when I multiply two fractions, I only multiply the levels of the fraction together. So this is really 4 over 1. So I do 4 times 181 and then 1 times 19. So that gives me negative 724 over 19. Okay with that so far, Mike? Okay. And then I'm going to subtract 9 from both sides. But to subtract 9 from 724 over 19, I need to have a common denominator. So I'm going to multiply 9 by 19 over 19. We okay there? So when I add those two fractions together, I get 895 over 19. And then I'm going to divide by 5, but instead of thinking about that as division, I'm going to think as multiplication by the reciprocal, since the other side is a fraction, It's more natural to think about multiplying two fractions than dividing. And if I do that, the 5 and the 895 will reduce to give me the 171 over 19 that I had advertised earlier. Does that feel okay, Megan? So the fractions made it kind of a pain, but the big takeaway was making sure at the beginning step here that we rearranged everything so things lined up before we started to do our elimination. Yeah, I mean, I could have plugged it in even here to one of those, and that would have been fine also. So wherever it just looks the most convenient, you can take your one answer and plug back in to any of the previous equations that you held that had two variables in it. Okay? Yeah, of course. Okay. Anybody else? Okie doke. Well, let's start today talking about our plan for today. So today we're going to talk about solving three variable linear systems. So this first example that we'll do both ways. We'll do as a substitution problem and also as an elimination problem. And then we'll decide which one we think is going to be the easier method. Sound okay? Okay. Okay. So one little thing to start with here is you'll notice that when I write my letter Z, I put a bar through it, as opposed to my number 2 that does not get a bar through it. I'm doing that on purpose because my penmanship is such that I couldn't tell the difference between a Z and a 2 otherwise. And it's been my experience that many students kind of run into the same issue. My recommendation is to you that you're putting a bar through your Z's so you're able to tell the difference between a Z and a 2. You don't have to do that. Some people write their 2's this way or something, and you don't. Like it's easy to tell the difference between a Z and a 2. But if you look at your paper and you're like, boy, I'm not sure I would tell the difference between a Z and a 2, especially when you start writing fast, try to get in the habit of putting the bars on your Z's. It's very easy to get confused on that. And have something that's like 5Z turn into 52, which makes a big difference in your problem, right? Okay. So let's talk about the plan here. Oh, yes. Oh, good point. Thank you, Connor. Yeah, that should be a Z. Thank you for pointing that out before we got started here. That makes a big difference. That's a Z, not an X. That was the typo. Okay. So let's do this as a substitution problem first. Sound okay? So I'll talk through the idea, and then we'll actually carry it out symbolically so you guys can see what's going on. So the plan here is we're going to pick one equation and one variable, and we're going to isolate that one variable. We're then going to use that to plug back into the other two equations, which will create two variable equations. We're going to simplify those down and then take those two variable equations and repeat that same process. We'll pick a variable from one of the two and isolate it and plug it back into the other, and that'll leave us with a one variable equation. And then from there, it's easy to solve. So if I look through here, which equation, we'll call these A, B, and C, and which variable from that equation looks like the easiest one to deal with, or the easiest place to start?
Maybe A, because there's no negative numbers.
Okay, so which variable from equation A would you want to isolate?
Let's isolate Z.
That would be what I would do. So equation A and variable Z, notice that the variable Z has no coefficient on it. So if I get Z by itself, I'm never going to have to divide, and I won't have the opportunity to create any fractions. As opposed that if I took equation A and tried to get X by itself, I'd have to divide by 4, which creates a fraction on Z. My goal here is just to avoid having to deal with fractions. Sometimes that's unavoidable, and that's okay. We can deal with the fractions if we have to, but they slow everything down, and if we don't have to deal with them by making good decisions, let's make good decisions and not have to deal with the fraction, right? That seems like a pretty good deal. By that same token, you could have certainly chosen equation B and isolated the Z also. The same situation is going on there. Those would be the two places I would consider. But let's do what Joe had suggested. So I'm going to isolate the Z by subtracting 4x from both sides and then subtracting 4y from both sides. Is everybody okay with that? All right. Then I'm going to take Z and plug it into B. And I'm going to take Z and plug it into C. Yes.
So when we plug in Z for B and C, do we not have to isolate one of the variables for B and C when we put the Z value in?
Correct.
So we can just put it in the way.
We can put it in exactly the way it looks.
Okay.
Yep. Which is what I've done here, right?
Yeah.
So you'll notice here that all I've done is I've taken my value for Z and I replaced the Z in equation B, and then I took my value for Z and replaced the Z in equation C. Does everybody see that there? I'm now going to simplify things down. So notice in equation one, in the modified version of equation B, there's no coefficient in front of that parenthesis, right? There's just a plus sign. Did you guys notice that? So that parenthesis really doesn't need to be there, so I can go straight to just combining the like terms and ignore that parenthesis. So I have 2x and negative 4x, which gives me negative 2x. I have negative 4y and another negative 4y. That gives me negative 8y. And then I have a plus 24 is equal to 0. I'm going to go ahead and move that 24 to the other side by subtracting. And I'm going to refer to this now as equation D. Now I'm going to simplify my modified version of equation C next. So here I notice that I have this negative 5 in front of the parentheses. So I need to start by distributing that. So negative 5 times negative 4 is positive 20. Negative 5 times negative 4 is positive 20. Negative 5 times positive 24 is negative 120. And then if I combine my like terms, 5x and 20x is 25x. Negative 4y and positive 20y is positive 16y. Then I still have the negative 120, and it still equals 12. I'm then going to add the negative 120, or add 120 to both sides to move that over to the other side. And this is what I'm going to refer to as equation E. Is everybody okay with what we've done to this point? Let's scroll that up a little. So I'm going to take equation D and equation E, and this is now going to form a two-variable system, just like we dealt with in last night's homework. So now I'm going to do another substitution. I'm going to look and I'm going to choose an equation and choose a variable from that equation to isolate and then plug it into the other equation. So looking at my choices here, what equation and what variable would be the best one to isolate?
Variable 1.
From which equation?
From D.
From D. Okay. Notice, though, that when I do that, I'd have to divide both sides by negative 8, which would create a fraction on the x, right? But if I use equation D and I isolate the x, when I divide by negative 2, I won't be left with any fractions that way, because 8 divided by 2 is a whole number, and 24 divided by 2 is a whole number. That's the route that I would go, because it allows me to avoid having a fraction. If you did something else, it's okay. You just have a fraction rolling around in there, which is not the end of the world. But if I don't have to have it, if I can look a little bit closer and avoid having a fraction, let's do that, right? Nobody wants to deal with a fraction if you could avoid it. So we will add 8y to both sides and then divide by a negative 2. And then what we'll do is we'll take that equation for x and we'll plug it into equation E. Oops, I swear I changed the color. So far, so good. Again, stop me if I do something that you're not sure about. So now I notice that I have just one kind of variable left, right? I just have y's. So I'm going to go ahead and simplify this equation down and solve for y. So I notice there's a coefficient in front of my parentheses, so I have to make sure I distribute that coefficient. So 25 times -4 is -100y. And 25 times 12 is 300. Then I still have that plus 16y, and I still have equals 132. I can combine -100y and -16y to get -84y. And I can subtract 300 from both sides to get -168. And when I divide both sides by -84, I get y equals 2. Everybody okay to there? So now that I have one of my solutions, or one part of my solution, I guess I should say, it's easy to get the other parts. So all I'm going to do is I'm going to take that answer and plug back in here to get the value for x. So x equals -4, and then I know y is 2 plus 12. So that's going to give me -8 plus 12, or x is equal to 4. Is everybody okay with that? And now I'm going to take y equals 2 and x equals 4 and plug them in here. So I have z equals -4, and then my value for x was 4. And then I have -4, and my value for y was 2. And then I have plus 24. So that's -16 minus 8 plus 24, which comes up with 0. So my solution then would be the ordered pair 4, 2, 0. I should say the ordered triple. So again, we always write our coordinate in alphabetical order, so we're always going to write x, y, z. So the order that we write them in as our coordinate is always in alphabetical order by the variable. So x, then y, then z, or a, then b, then c, or L, then M, then N, or whatever the letters are. Okay, so that was a lot, right? Let's go ahead and do this same problem then. And this time we'll do it by elimination. We'll see which one we think is easier, which one we like better. Okay? Because it will make no difference to me on these 3 variable ones. I'm going to let you do what you're most comfortable doing. So on the test or the quiz or the homework or whatever, I will give you the freedom to do these problems whichever way you'd like, because they're kind of take a little bit of a little bit of doing. You know, they're a little bit lengthy. And I think it's important to do them the way that you feel comfortable. So we're going to do the same problem, this time doing elimination. So before we go ahead and do that elimination, let's talk through what the idea here is. So what I'm going to do to start is I'm going to do two eliminations. I'm going to pick two pairs of equations. They have to be different pairs. And from each of the pairs, I'm going to eliminate the same variable. So I could eliminate x's from each of the pairs. I could eliminate y's from each of the pairs. I could eliminate z's from each of the pairs. That part doesn't really matter, but it has to be the same variable from each of the pairs. Okay with that? So once we've done that, those two eliminations, we're going to be left with two variable equations that'll form a new two variable system. We'll do one more elimination, leaving us with one variable that we can solve for. Okay. So the place to start here would be looking at our equations here, A, B, and C. What looks to be the easiest variable to eliminate? Not that there's a wrong question, any variable is fine, but if we can make our life easier and pick things that work out nicely, let's try to think ahead a little bit and see if we can notice anything that would make this easy. Who thinks the y's would be the best one to use? I think that's going to make life the easiest, because I noticed that if I add equation A and B together, the y's are going to cancel. I don't have to do any multiplication at all to make that happen. Do you guys agree with that? And similarly, if I add A and C together, the y's will cancel and I don't have to do any multiplication at all to make that happen. That would be, I think, the easiest route to go because you don't have to multiply any equations by anything. Do you guys see that now? So ideally, that's what I'm going to start with. So I'm going to do equation A plus B, and then I'm going to do equation A plus C. Oh no. If you need to go get some paper towel or whatnot, I have some stuff up here too that you can use that'll be a little bit more absorbent. Okay. So I'm not going to rewrite equations A and B and A and C down because I didn't multiply them by anything. They didn't change. They're just right there. So I'm just going to add them up from the problem. It's certainly not wrong to have to rewrite them or whatever, but we don't need to do that. So 4x and 2x is 6x. 4y and negative 4y is 0. Z plus z is 2z. And 24 plus 0 is 24. I'm going to refer to this as equation D. Now let's add up A and C. So 4x and 5x is 9x. 4y and negative 4y is 0. 1z and negative 5z is negative 4z. And 24 and 12 is 36. I'm going to refer to this as equation E. You guys can take the trash can back there so you don't have to bring the drippies all over the place too. It's certainly okay. Thank you. Yes. Because I didn't add equations B and C together. I added A and B and then A and C. Is that cool? Okay. So, and I intentionally did that because I would have to I'd have to multiply by a -1 if I tried to add B and C together. And that's fine to do, but if I don't have to do any multiplication, let's not do any multiplication, you know? Is that cool? Megan? Well, I didn't add all three equations together at any point, though, right? I added A and B, and then I added together A and C. Yes. So I did equation A plus equation B. That has no y's left. And then I did equation A times equation C. That has no y's left. I at no point added all three of them together. Do you see the difference? Okay. Let's keep going, and if it's still unclear, we can always circle back and talk about it some more, okay? So these two equations now form a new two-variable system. Notice in this new two-variable system, I have just x's and z's. So at this point, we're going to do another elimination. Which variable would you like to eliminate first here? Well, first question, does it matter which variable you choose? Not really, right? Which one appears to be the easiest to get to eliminate? The z, because I only have to multiply one of the equations instead of both of them. Everybody agree with that? So let's eliminate the z's. So to get them to eliminate, I need to multiply equation D by 2. That'll give me a 4z that when I add it to a -4z will give me 0. So 2 times 6x is 12x. 2 times 2z is 4z, and 2 times 24 is 48. And then I'll just recopy down equation E, and then we'll add those. So I'm left with 21x, the positive 4z and negative 4z cancel out, is equal to 84. And when I divide both sides by 21, I get x equals 4. So far, so good? What am I going to do with x equals 4? I'm going to plug that back into either of the two variable equations. So I'm going to plug it into either equation D or equation E. It doesn't matter which one. I'm going to choose to plug it back into equation D because the numbers in equation D are a little bit smaller. So it'll make the arithmetic a little bit less tedious. So 6 times 4 is 24. If I subtract 24 from both sides, I get 0. If I divide both sides by 2, I get z equals 0. Is everybody okay there? Okay. Now that I have two parts of my answer, I can find the third. So to do that, I'm going to take both of these parts and plug them back in somewhere into equation A, B, or C. So for the sake of argument, I'll plug these into equation A. It doesn't really matter which one you would have chosen. So we have 4 times x, which is 4, plus 4 times y, plus z, which is 0, equal to 24. So that's 16 plus 4y plus 0, but I'm not going to write down the plus 0, equals 24. I subtract 16 from both sides to give 4y equals 8. And I divide both sides by 4 to get y equals 2. Leaving me with my solution 420. Megan, does that feel okay on what we did there? Did it clear up after we finished to kind of see? Okay. So let's just kind of compare these two methods here a little bit. I can't make them any smaller to get on the same screen. So if I compare them, it certainly looks like there was more writing when we did the substitution, right? So there's substitution, there's the elimination. What part of the elimination took a little bit more time than the substitution did? Well, I think that when we had to go back and plug things in, that took a little longer than it did for the substitution because we already had the variable part isolated when we went back to plug things in. But that's pretty trivial that it got shorter. The big, I think, disadvantage of the substitution is in this step here, where things get longer before they get shorter, as opposed to in the elimination step. Look at how easily we got our 2-variable system. We didn't really have to do much in order to spit that right out. Personally, I prefer elimination to substitution when the problems get bigger like this, I think it's less writing involved, and in turn it lets me go faster. But you can do whatever method you feel like. Okay. We have 35 minutes or so left in class, right? What I want you guys to do is I'm going to post a assignment. I think it's got 5 3-variable systems. And I'd like you to spend the rest of the time in class working on this. So if you get stuck on things, or you want to ask questions about things, or you want to check your answers with me, you have an opportunity to do that before you have to take this home and finish it by yourself. Because I know this is a long process and probably looks quite difficult. It's not so bad once you get the hang of it, but it helps to get the hang of it if you're able to ask your questions as they come up, right? So that's what we're going to do the second half of class here. Sound fair? Good, you didn't have a choice. That's what we were going to do, even if you argued with me about it. That was supposed to be a joke. So I'm going to turn off the recording now.